In this final podcast, we're going to be solving rational inequalities using a graph instead of a sign chart. To begin a problem like this, we have, in this particular example, we have two rational functions that are being compared to each other. It's much easier to solve if we compare to 0. So the first step will always be to set it equal to 0. So I'll begin by subtracting the 5x over the x plus 1 from both sides and comparing to 0. Now this is a more complex rational equation certainly, but it's much easier to compare to 0 because 0 is just the x-axis. So the question is really, when is this thing going to be above or on the x-axis? Now we can do some of our thinking in advance. If we look at the denominators of these fractions, for example, we know that x can't be 2 because that would make this function undefined, and we know that x can't be negative 1 because that would make this function undefined. So I am thinking that we're probably going to have vertical asymptotes at 2 and at negative 1. So I'm going to go ahead at negative 1, and I'm going to draw a vertical asymptote, and I'll do the same thing at 2. Now there is a possibility that one or both of those are holes in the graph, but it's fairly unlikely, and we'll know better when we graph. So what I'm going to ask you to do now is go ahead and pause the podcast and graph this function on your calculator. Call that y1. And just a little caution, be sure to put some parentheses in all of these locations as you do the graph. All right, now that you've paused it and you did that graph, hopefully you'll see something that looks like this. We did have, in fact, vertical asymptotes there. We also have a horizontal asymptote somewhere down here. And the graph looks sort of like this. There's a branch of it here. There's a branch of it over here. And there's another piece of the graph that goes something like this. And sorry, that might not be very nice, but that's what they look like. So let's go ahead and start to analyze our results. And I'm going to start with this. It says greater than or equal to 0. So let's start with, where does it equal 0? It's going to equal 0 anytime it crosses the x-axis, and that is right here near 0. And then there's another point right here where it's crossing. And it looks like on my graph that it's on the asymptote. It's certainly not. It'll be to the right of the asymptote. I want you to go ahead and pause the podcast again and use the 0 feature of your calculator to find those values. Now I did the same thing that you did. I used the 0 feature, and I found that this value is at 2.81 and that this value is at negative 0.21. Now in looking at the remaining part of the graph, what I want to know is, where is it greater than 0? So let's now go ahead and look at each region of the graph. There are some natural breaking points in the graph. The natural breaking points would be the asymptotes and the zeros. So we're going to look in between each of those. For example, here's the first breaking point, is this asymptote. To the left of this asymptote, the entire graph is below the x-axis. Therefore it's negative. I'll put a little negative here in the graph. From the first asymptote to the 0 that we have here, all of the graph is above the x-axis, so I'm going to put a little plus right here for positive. The next point would be from the 0 to the next asymptote where the whole graph is below. We'll call that negative. From the asymptote to this 0, that's this piece right here, and I know they kind of coincide there, but it is positive there. And then after that, we do have a negative. So what we really essentially are doing here is making a sign chart. Now I'm going to use that sign chart to analyze my final results. The question is, where is it greater than 0? What's greater than 0 whenever it's positive? Now the asymptotes themselves, of course, can't be included because they make the function undefined. So I'm going to put an open circle here, and at the asymptote, it will be positive in this region, from where the plus is here, from the asymptote to the first 0. It will also be positive from the asymptote to the second 0. So I'm ready to go ahead and write what my answer is now. The first asymptote we know is at negative 1, so it's going to start at negative 1, and you'll notice that I didn't include that because it is an asymptote. It'll never be included. It will go until we get to that first 0, which happens at negative 0.21. That is included because it is 0, and it does it greater than or equal to 0. It will pick up again at the next asymptote, which we know is at 2, and the asymptote, of course, is not included, and it will go to the next 0, which is at 2.81. And that 2.81 is, of course, included. Had this said, where's it negative, my whole result would be different, and I won't write it, but I'll state it. If I'd asked, where is it less than or equal to 0, then I would say from negative infinity to this first asymptote at negative 1. Then from negative 0.21 to the asymptote again, it's negative. And then from the final 0 to the right forever, so from 2.81 forever, it would be negative as well.